Hi guys, this lesson today is on reference angles and coterminal angles. We get to use some of our new learned trig skills in this lesson, so to me it's fun. I enjoy doing trig. It's a little bit more tangible than some of the other things we've been doing, so that's why I like it. Before we jump into the notes, I actually want to take a step back and talk about what is a reference angle, what is a coterminal angle, and why do we care, why would we need them. So I'm going to start a new page here. You don't need to write this down, but I'm just going to go through and explain why we need them or what they are. So a reference angle, I'll just start with reference angle because that's what started in the notes. That's the first thing that's mentioned in the notes. A reference angle is if you drew an angle somewhere, like let's say I come down here to the third quadrant, and let's say I draw an angle down here. So this angle, we always start an angle here and in the initial position, and then we rotate around and we have this angle over here, which is going to come down into this position. Okay, if we are talking about this in degree mode, then we're going to come over here, we're going to go all the way past the 180 degree line, we're going to come down a little bit more, this is now another 30 degrees, so I'm all the way down to 210 degrees, because remember I always go in counterclockwise motion when I'm doing these trig angles. So I here have a 210 degree angle. Now the thing is, we pretty soon, in a couple of days, are going to start doing some SOHCAHTOA. And if you look at that angle and start thinking about opposite and adjacent and a hypotenuse, that's kind of confusing for that huge angle. And so what we do instead is we say, you know what if we just take a different angle? And what if we just take this one? And a lot of times in trig we use this theta for our angles. So what if we just call this our theta? Instead of the whole thing, what if we just call this our theta? In this case, I'm talking about this 30 degrees. And so then, if we drew our triangle now, like if we created a triangle with this, we could do SOHCAHTOA now. We would know how to do SOHCAHTOA with that triangle. So that is why we have reference angles. That's one of the reasons why we have reference angles. So it's so that you can do something with it. It's just difficult to do something with that huge, that big, obtuse angle. It's not even obtuse, it's more than that, and make it useful. That's a reference angle. Coterminal angle. Let's say that you are supposed to go a certain angle. I don't know. Let's just say 210 again. Let's say I'm going to go 210 degrees. And so I'm going to take my angle and I'm going to come all the way over here and I'm going to go 210 degrees like this. So there you are. There's your angle. And your friend says, well, that's interesting. Why'd you go that way? Because if I was going to end up in this spot, this 210 degree spot, I wouldn't go that way. And your friend says, you know, maybe they don't know anything about trig and they don't know anything that you're supposed to go counterclockwise. So they go, you know what, why not just go this way instead? What if we come over here and we go this way? And look, we're at the same place. We went different ways, but we ended up at the same place. Those are called coterminal angles. Because co means together and terminal means the end. So they ended at the same spot. So it doesn't matter whether you go that way, which is 210 degrees, or whether you go this way, you're going to end at the same spot. And so if this first one that I drew was 210 degrees, how many degrees is this one down here? Well, we went in the negative direction. We weren't supposed to go that way. Your friend didn't know. They didn't know you're supposed to go the other way in trig. So this way, well, if we went all the way, it'd be 180, but we went less than that. We went 30 degrees less than that. So that was 150 degrees, a negative 150 degrees. And so the numbers 210 and negative 150, those are coterminal angles. Notice, if we took the absolute value of those, what's the absolute value of those added together? They add up to a whole circle. Okay, so whether you go this way or that way, they're coterminal, they end at the same spot, they end up in 360. Okay, let's go to the notes now. I just wanted to make sure that you understood even why we're doing this or the background. Okay, so a reference angle, that was the one we talked about the first time, that you have an angle of some sort, and the deal is with a reference angle, you always go back to the x-axis. That's important. So the x-axis is our reference point. So if your angle is in the first quadrant, then the reference angle is the angle itself. That's just what it is. If you go a little bit farther and now you're over here in the second quadrant, well, now your reference angle is the 60 degrees over here because we want to go to the closest, the nearest x-axis. I'm going to write the nearest in there. So you just find your nearest x-axis and you say how far away is the closest x-axis. Quadrant 3, let's say you're down here. Well, now the closest one, the closest x-axis is right here, and that's your reference angle. And in quadrant 4, your reference angle is over here. You have to think about just the nearest x-axis. And so you know from your unit circle that the whole way is 360, half the way is 180, so just figure out how far away from the 180 is it, or how far away from the 360 is it. Sometimes we ask for this in degrees, sometimes we ask for it in radians. That is reference angle. You know what, before we go on to coterminal, let's talk about reference angles and do a couple of examples. So when you do these, you don't need to draw a diagram, but sometimes I think it's easier to. Or maybe you just have a unit circle in front of you that you're looking at. So 30 degrees, I think that's a pretty easy one. It's in the first quadrant. We go to the nearest x-axis. That's right there. That is 30 degrees. 260, where is that? Well, I'm just going to use that same one. 260, well, this one is 180, and this one is 270, so 260 is like right here. Where is the nearest x-axis? Well, it's right here. How far away is that? Well, this again, this was 260, and that was 180, so how far did we have to go to get from 180 over to 260? Another 80 degrees. So 80 degrees is the reference angle for a 260 degree angle. 135 degrees, negative 135 degrees. So if I go in the negative direction, this is a negative 90 degree. This is a negative 180 degree. So a negative 135 is like over here. How far away is that? Well, you can think about it from the 180 or you can think about it from the 90, but really let's stick with the 180 because we want to stick with the x-axis. So how far away is that? Well, how much farther would we have to go to get to the 180? We would need to go another 45 degrees to get to the 180. 460. That means that you started at the initial point, the initial angle, you went all the way around plus 10 more. And so that is 460. The nearest x-axis is 10 degrees. Also notice that all of our reference angles are always positive. We might write that up at the top because it's really just an absolute value. We're just looking at how far away, and distance is absolute value, so that's just a positive number. You don't have to worry about left or right or up and down or whatever, clockwise, counterclockwise. It's just always positive. Okay, negative 200. Once again, the negative direction means that if we start here, we're going to go negative 180 plus another 20 extra to get over here. So where is our reference angle? Our reference angle is right here, and that is 20 degrees away from the x-axis. All right, that's how we do it in degrees. Of course, we have to do it in radians also. So now we have to start thinking in radian mode. So turn your brain over to radian mode. Okay, and maybe you're not very good with radian mode yet, so let's maybe think about it. Well, the 180 in radians is pi, and over here we either have 0 pi or 2 pi. And so up here we have pi over 2, down here we have 3 pi over 2. And this might be one where you just have your unit circle in front of you with all the radians marked on it that we worked on yesterday, and that might be easier for you to deal with. Okay, so if I want to find a pi over 4 radians, well, this is pi over 2, so pi over 4 must be here. How far away from the x-axis is that? Well, two things. One is it's in the first quadrant, and our notes up above say if it's in the first quadrant, the answer is the angle itself. So pi over 4 radians is the reference angle. Another thing, just look at how far away from the x-axis is it, and that's how far away it is. Okay, number 7 says negative pi over 6. That's a little sliver, right? Okay, first of all, it's negative, and it's just a pi over 6. That's not very much. So it's going to be going over here. And how far away from the x-axis is that? Well, it's pi over 6 radians. Okay, number 8. Once again, if you need to look at your unit circle, that's fine because we are new to these radians. Negative 2/3 pi radians. So think about your unit circle. If you're going in the negative direction, this will be negative pi over 2. That's like a half. That's like 0.5, but this is negative 0.66, so we need to go farther than that. So we're going to go like over here. It's hard because I drew it so small, but this is going to be a negative 2 pi over 3. And so your nearest x-axis is up here. And going with radians, if I go over here and I'm going in the negative direction, that's like a negative pi over here. So how far away is 2/3 pi from a whole pi? Well, it's pi over 3 away. And I should label that radians. So pi over 3 would get me from negative 2/3 all the way up to 1. That's a third of the way over, a third more pi's. Some of this is, can you think in fractions? And so if you're having a hard time with radians, that might be the fraction thing. But that's how far away you're going to get from pi to 2 pi over 3. You're going to have to go another third to fill out that pi. Okay, number 9 is 5/6 pi radians. Well, that's almost a full pi, right? So we're going to go around here, but we're going to stop just short of a full pi. Well, how much short did we stop? Well, again, in the positive direction, this is going to be a pi over here. So we stop a 1/6 short of a full pi radian. So this is pi over 6 radians. That is the reference angle. The reference angle is always going back to the x-axis. Okay, last one, number 10, is it's more than 360 degrees, right? So we have to think about what that is. Try converting that to an improper fraction. So 4 would go in there 3 3/4. 3 3/4 radians. So I need a pi. So 3 3/4 pi radians. So here's 1 radian, here's 2 radians, here's 3 radians, and then we need to go another 3/4 of a radian. So it's all the way over there. Now, how far away from the x-axis is that? Well, it's 3 3/4. We would just have to go another fourth to get to our destination. So that's pi over 4 radians. Okay, that is reference angles.